Hi, my name is Jacob, and in this video series I'll guide you through the process of creating your first URcap. In this video we will deploy and test our URcap in polyscope. For the sake of demonstration, we will create the light up URcap. In this case, the URcap can be used to turn on a digital output on the robot for a given number of seconds before the output is turned back off. The URcap is built and optionally deployed using Apache Maven. The POM file is configured to build the URcap and can deploy in 3 different ways. The first option is manual deployment. In this way, the URcap is just built, and you will have to manually get the URcap file and install it on a robot using a USB. This is typically the way you use when the final URcap is ready for distribution. The second option deploys the built URcap to a local ursim. By local is meant that the Maven tool is executed in the same environment as the ursim. As a third option, you can build the URcap and deploy this to a remote ursim. This is typically if your ursim is running in a virtual machine separate from Maven. If you have a physical robot next to you and is connected to the same network, you can use the fourth option to directly deploy the build URcap to the robot over Ethernet. The robot will then reboot and the new URcap will be installed. In our case, we are using the URcap starter package, in which case Maven is in the same environment as the ursim. We'll hence use the local ursim deployment option. When deploying to a local ursim, the first thing we need to do is to locate the appropriate ursim. To do that, start a new terminal pressing Ctrl-Alt-T and then navigate to the ursim folder using CD and then ursim. As we open this folder, we can use ls to list the contents of this directory. In our case, we can see that we have a ursim 3.6 and a ursim 5.0 installed. For now, we want to deploy our URcap to the ursim 5.0. and hence we need to be able to remember the location of this ursim. In this case, it's the home folder, then the user UR, and then inside the directory ursim followed by ursim-503 30.563. Now we need to configure the appropriate ursim inside the POM file of our URcap. To do this, start by opening the POM file. As the POM file is open, we can now go to the raw POM view. In the POM view, we can see these 3 sections. The first one describes the installation and deployment to a network robot. The following one to a local ursim, and the last one to a ursim inside a separate virtual machine. In our case, we want to deploy our URcap to a local ursim. Hence, inside the ursim home tag, we'll add the location of the appropriate ursim. In our case, the location here is home/ursim/ursim-5.0.3.30.563/. Now when we deploy the URcap to this ursim, this is the path that will be applied. Now save the POM file. Now we want to use Maven to build and deploy our URcap to polyscope. To do this, start a new terminal pressing Ctrl-Alt-T. Now we want to navigate to the location of our URcap, which in this case is located inside the workspace folder. Hence we'll use CD and workspace and then locate our URcap folder, which is called com.jvm inc light up. Hit enter. Then we write mvn install. Writing mvn install will build the URcap for mainly manual deployment. If we add -P ursim after the URcap is built, it will also be deployed to the local ursim. So in our case, we use mvn install -p ursim and hit enter. As we hit enter, the URcap will now start building. Upon a successful build of this URcap, it will automatically be deployed to polyscope. Upon the successful build of our URcap, we can now start polyscope and test out our URcap. To start polyscope, start a new terminal pressing Ctrl-Alt-T. Now navigate to the appropriate ursim using CD and ursim, and then ursim 503 where we just deployed our URcap. Inside this directory, we want to execute the file start ursim. To do so, use /start ursim.sh. Hitting enter will start up our polyscope, and then we can soon test out our URcap. Now polyscope starts it up, and we can move into the program domain and find URcaps, where we now have our light up node. By clicking the light up node, it is inserted into the program tree. And first we notice that we have the name light up here as returned by the program node service, and the title light up :do0 t=1 as returned by the contribution. Inside our node, we can open our combo box or drop down and select the digital output between 0 and 7, for instance choosing digital output 1. We can see the name is reflected in the program tree. Also, we can use our slider from 0 seconds to 10 seconds to toggle the duration of the operation of our node. We can insert multiple nodes into a program tree, any of them starting with the default values. Hence we can change the digital output 2 for this node and a duration of 1 second. So now we have 2 nodes available, and if we want to test these out, we can boot up our robot. Now our simulated robot is started up completely. We can go back and start executing our program using the play key. Now our program is executing, and we can go into the I/O tab and inspect that our digital outputs 1 and 2 are toggled respectively turning on digital output 1 for 2 seconds, followed by digital output 2 for 1 second. And hence our node is working as expected.